over here that is perpendicular to PQ, and then we're also given the height SU over here that is perpendicular to QR. Okay, so I know that this is a parallelogram. If I were to take 10 meters as my base and 11.2 meters as my height, base times height will give me the area of parallelogram. The parallelogram does not change even if I take a different base and different height. So if I have PQ times 8 meters, it should also give me the area of parallelogram. So therefore I can form an equation that tells me that 11.2 times 10 is equals to 8 times PQ. Okay? Because the area of parallelogram doesn't change, right? Just because you take a different base and different height. Okay? Because the base and height are corresponding, comes in a pair with one another. Okay? So then you can find out what is PQ by 11.2 times 10 divided by 8. Right? So I'll leave that part of the working, the main part of the working to yourself. Next, for question 5. We're given a rhombus. Okay, and this area of the rhombus is given to be 44.8 centimeters squared. Okay, we want to find a perimeter of the rhombus. That means that I must know what is the length of all the different sides. Now, because this is a rhombus, all the sides are actually equal to one another. I know that I have this 6.4 cm as the height. Okay, if I were to choose the side that is perpendicular to the height, it will be BD. Okay, and since this is a rhombus, it is also a parallelogram. Okay, so base BD times AE will give me the area of the parallelogram or the rhombus. Okay, so BD times 6.4 gives me 44.8. That means that I can find out what is BD. Okay, and then subsequently I can find the parameter, because the parameter will be 4 times of BD because all the sides are equal in length. Okay. So I leave you to fill in the blanks. Right? Then question 9. We're given a trapezium for which the area is 185 meters squared and the perimeter is 61 meters. We want to first find out what is the length of RS, and RS is this length over here. Okay, so since we are given the area, which is 185, we know that half times the sum of parallel sides times the height will give us the area, because that's the formula. Right? So half times the sum of parallel sides will be RS plus 12. Okay, because those are our parallel sides, followed by times 10. Taking note that my sum of parallel sides must be in brackets, okay, because they are together. Right? And this must be equals to 185. Then we need to simplify this. So half times 10 gives us 5. So 5 times RS plus 12 is equals to 185. Okay, whenever we need to solve for RS, okay, we need to take the 5, 3 to the other side first. We take the things that are outside of the brackets first, okay, before going inside. Okay, just like how you take off your clothes when you want to go home, when you go home and then shower, right? Okay, take out what's outside first before you reach the inside, right? Okay, so RS plus 12 equals to 185 divided by 5. Okay, so take it outside first, right? Then after you can find out what's RS. Okay, then QR, okay, will then be the remaining side. So because we know the parameter is 61, since I already know what is RS from the previous part, okay, so I take the parameter minus RS minus 13 minus 12, and then you get an answer. Okay, so I expect that you know how to get the remaining side. So this is pi. Then the last one, question 13. and its dimensions are shown. We want to find the area of the cross section of the school. Okay, so to find out what's the cross section, that is actually this entire thing. Okay, so what we need to observe is that we can find the area of the big trapezium minus away the area of the small trapezium. Alright, so then we apply our area of trapezium formula. Alright, so in part I, area of cross section will be equals to area of the big trapezium will be half times sum of parallel sides 35 with 45 times the height 30 minus away the area of the smaller trapezium, which is 15 plus 30 for the sum of parallel sides, followed by the height 50. Okay, so if you were to calculate this, you will be able to get an answer. I'll leave it to you again to do your calculations. Okay. Then in part 2, we are given a different cross section, whereby we have a trapezium and then also a semicircle. Okay, we want to find whether there is a percentage increase or decrease. So first of all, we must know what is the area, okay, in this cross section over here. Whereby the logic still remains the same as what we did in part I. We take the area of the big trapezium, but this time around we minus away the semicircle. Okay, so the area of the new cross section will be to take the original trapezium minus away half times pi r squared, taking note that the radius is 30 divided by 2 because what we're given is the diameter, and of course this is a semicircle, that's why we take half times pi r squared. Okay, and then we'll get a certain value for which usually the answer is truncated 5sm. Okay, sorry, someone give me what's the answer in part I? Sorry? 862.5. So this is exact value, right? Cm squared. How about part 2? 846.57. Okay. Alright, so truncated 5sm. Then after that, your percentage increase or decrease in this case. We see that the original is 862.5, now it's 846.57. So therefore there's a percentage decrease. Okay, because the value has decreased. So we find out what is the difference. Okay, divide by the original times 100%. Okay, and then you get an answer. Right? Yep. If this answer is high, you can not an issue. Right? Any other questions? Okay, if not, once you're done, please submit your homework down to the front. Francis, I have your chapter 10 homework here. I'm going for competition later. Good luck. You know what's happening today? No. The C boys are going to play their national finals. Yeah. big, very significant milestone in our school's career. Okay, and Lucas is part of it, right? Lucas, okay, are you part of this? You're part of the team, right? Okay, so I think something that we are very proud of is regardless of the results that we have. Okay. You know when was the last time we ever had this? How long time? I guess. How long time?
10 years ago.
10 years ago. It was 2011. Yeah. The last time, that's what I heard. The last time that our school managed to go into national finals for our C Division boys, if I'm not wrong, is 2011. Okay, can you pass forward now to the front, please? Because these are not exact values, so 3x. Okay, for repeat, could you all take out your chapter 13 notes? I've given out your chapter 13 notes, right? Have I?
How much? Oh, so they deliver the card and
No, I got the lucky draw in Korea. I went to Korea.
这个是我韩国的一个同学，然后即使澳公出来不是他妈妈出完回来了好多本，就为了拿到全套的那个。现在只差一个就有全部，反正即使澳公考全都有。对，那个巨便宜。
Could you help me refresh my memory? Have I gone through this question?
Which one?
Have I even started on chapter 13 review? I have, right?
Yeah.
I have brought you all to convert units already, right? Okay. Have I gone through this for example here?
I think yes.
You think, can I have a confirmation? Can you look at your notebook? No, the exercise one are prisms and cylinders. Have I done this? Yes. Yes, okay. How about this one? Practice now 2 questions. No. I have not. So the last one that I did was I stopped here, is it? Okay, then. I thought I wrote example 2. Okay, so that means I have not yet done this. Thank you, Cynthia. Okay. Sorry, because when you teach 2 different classes, I get very lost sometimes. Okay, let's look at this question. We are given that there is an open rectangular tank 55 cm long, 35 cm wide and 36 cm high initially half filled with water. We want to find the depth of water in the tank after 7,700 cm3 of water is being added. So it is helpful if you have a diagram to visualize what the question is saying. So we start off with the first part. It says that there is a open rectangular tank. Okay, that means that it is a cuboid. So up to you over how you want to draw your tank. I tend to draw tanks like that. However, I do notice that one of my colleagues has a very interesting way of drawing tanks. She draws two rectangles that overlap each other like that, and then she connects it, which I thought was also quite smart. Okay, but I don't have a habit of drawing tanks. You'll see, right? Okay. So, anyway, so in our tank we have 55 cm long, 35 cm wide, and 36 cm high. Okay. It is initially half filled with water, so I'm going to fill it into half. So more or less something like this. Okay, half filled. And then we want to find the depth of the water in the tank after another 7,700 cm3 of water is being added in. Okay, so that means that your water level is going to increase, and how it will look like. Okay, might be something like that. So what the question wants is that, what is this height in? Okay, so I hope we all understand the question now. Right? So first of all, we know that initially it was half filled. That means that this height over here, can you tell me how high would the water level be? If it's half filled, how high would this be? 36 divided by 2, right? So that will be 18 cm. Okay, so our initial height, okay, will be 36 divided by 2, 18 cm. Okay. So we know that this additional amount, okay, is going to have a volume of 7,700 cm3. Right? And because this is found inside a cuboid, okay, the volume of this water here that is in red, it will be having the length 55 times the breadth 35, followed by the height here, okay, which I will label it as H. Right? So to find out the volume of this water, this additional layer, it will be taking length times breadth times height H. So I will let additional height be H. So 55 times 35 times H will actually give us the volume of the water, 7,700. That will allow us to find out the value of H. Okay, whereby 7,700 divided by 35 divided by 55, that will give us the value of H. That is equals to 4. Okay, and therefore my end result, okay, my final depth of water will actually taking the initial height of 18 plus 4, so that will give us 22 cm. Questions? Any questions so far? rectangular tank. So this is open. Okay, I hope you remember what is open. Open means that there is an opening at the top, right? So this concrete rectangular tank has a dimension, okay, of 180 by 120 by 30 by 80 cm. Right? Then there's a concrete thickness of 30 cm all around except at the top. I hope you realize that it doesn't make sense to have a 30 cm thickness at the top because it is open, right? Okay, so you want to find the volume of concrete being used. That means you're looking at the amount of concrete on the external, on the outside of the space, okay, that we have on the inside. So that means that in order to find the volume, okay, what should we have to do? We need to take the bigger cuboid minus away the smaller cuboid on the inside. You all see that? Right? So that means that, okay, to find the volume of the bigger cuboid, okay, I'll call it volume of external cuboid. That will actually be length times breadth times height. That's our formula. So our length over here, 180 plus 30 plus 30. So if you were to compute that, that will be what? 240, right? And then the breadth, okay, here will be 180, followed by the height, okay, of 80 plus 30, that will give us 110. Which leads us to 4752, followed by 3 zeros. Okay. Then now we need to find the volume of the internal cuboid. Which would then be to take 180 times 120 times the height here, which is 80. And that will give us 1728, 3 zeros. Okay, then we want to find the volume of concrete used. So we will take the difference. And we get 3,024,000 cm. Is that all to this question? Yes, see? Yeah. Okay, so this question says change to meter cube, right? You want to give your answer in meter cube. So actually, right at the start, there are several ways to actually go about doing this. You can have your answers all already in meters, okay, so that your final answer will be in meter cube, right? That might be easier for some of us. You don't need to worry about the conversion, okay? But then, otherwise, if you're like me, you get your answer in cm cube, we need to know how to do the conversion. So let's recall 1 meter is equals to 100 cm. So 1 meter cube is equals to 100 cube cm cube, which is in fact 1 million. Okay, so that means that our 3024 and then 3 zeros cm cube will be equals to taking 3024, 3 zeros divided by 1 million. Okay, and then we get 3.024. down when you finish question 1, then you may move on to question 2, alright?
So,
What's this? I know this is backpage to some right?
Yeah.
We have the backpage one. And notice some of you are having problems in finding total surface area. I encourage you to draw out the void. Okay, so that you can visualize what are the different surfaces or faces that you need to calculate. Okay? If I write your name on the whiteboard, please write answers on the board. Say it right.
it has to be raised up.
Next, seems like you get the half response. Not sure? Okay. Alright, so let's take a look at the answers. You see whose answers correct? Okay, exercise by PCT. Serious answer is correct, right? Okay, just maybe presentation wise, okay, we write 400 at the bottom now. Right? You don't have more than one equal sign, okay, along the same line frame. Right, and then indicate very clearly volume equals. Okay, then in part 2, we want to find the total surface area. Now this is a cuboid, right? So say, what do you try to find? A cube, huh? Okay, so therefore the calculation is not correct. Alright, so looking at this part over here, okay, how we want to go about finding total surface area, we can consider looking at front, back, top, bottom, left, and right. Okay, so we need to consider all the different 6 perspectives. Right? So, to find out the total surface area, what we will need to do is that, okay, maybe we consider top and bottom first. Then that will be 8 times 5. Okay, and then at the top is also the same rectangle of the same size. So we will do 2 times 8 times 5. So this is my top and bottom. Okay, followed by adding with, considering maybe the left and right, okay, which will be 5 times 10. Okay, so we got top and bottom, left and right already. We have not yet calculated front and back. So at the front, it will be 8 cm along with 10 cm over here. My diagram is not quite proportional, but it at least still serves its function of helping me see the different 6 sides. Okay, then we will add all of this up. We can press it into our calculator directly, such that we will get 340 cm squared. Okay, yes. Yeah, can. Not issue, they're all the same, right? Okay, any questions? Okay, so I hope that we are clear about this. I know that I've already given you your SLS to learn about volume and surface area of prism. I'm not sure whether you recall, okay, but prism there might be a different formula that's been introduced, finding the parameter of the cross section times the height. Okay, but I think when it comes to cuboid, you can stick with this first. Okay, I'll come back and consolidate it when we see each other too. Alright, so let's move on. Let's look at question 2. In question 2, we again have an open rectangular tank of length 16 and breadth 9. Okay, so let's draw another tank. Okay, so length 16, breadth 9. It contains water to a height of 8 cm. So maybe up to here, 8 cm. Okay. We want to find the volume of the water in the tank, giving our answer in liters. Okay, so since our units are all in cm, so let's find the volume in cm cube first. So volume of water, that will be equals to 8 times 16 times 9, and that will give us 1152 cm cube. Okay. So how do we convert from cm cube to liters? Okay, if you recall, cm cube and milliliters is actually the same unit, right? So the values are equivalent. Milliliters to liters, we know that we can divide by 1000. Right? Such that my answer will then be 1.152 liters. Leave our answer in exact. Okay. Part 2, we are given that the surface area of the tank that is in contact with the water, okay, is what we want to find. So this is the water over here. Okay, the surface area that is in contact with the tank would consist of the front, okay, not forgetting that this is 3-dimensional. So it fills up all over. Okay, so we got the front, the back, the left, the right, we got the bottom, but do we have the top? Don't have, okay, so therefore we will consider 5 surfaces when calculating our surface area. Right, so could I just give you 2 minutes to do this calculation to find the surface area of the tank? Okay, so we consider front, back, left, right, bottom. Top don't have. Okay.
现在只能看见所以把闪的送给他。
What's the answer?
6.
6. 544. David says 544. Question, what's yours? 560. Okay, let's check. So we said front and back, right? So the front rectangle is 16 times 8. And then you have front and back, so we times 2. Okay? Left and right. So right side, you have 9 cm times this height 8. So we will plus 2 times 8 times 9. Right? And then we said that at the top don't have, only at the bottom rectangle is 16 times 9.
Oh.
Okay? So upon adding all of this up, we should get 554. Right? 44. Right? Oh, sorry. My hand and my brain didn't connect. Okay, 544. Okay? Sylvia, having your book on your head doesn't help you to absorb it faster. Right? Questions? Okay, so let's look at the last one. Okay? For this session. It says that a metal cube has a volume of 27 cm cube. It is painted on all its faces. So we're looking at the cube. So something like that. We want to find the total area of the faces that will be coated with paint. Okay, so like what Zach was doing just now, if I know the length of each side of the cube, okay, I just simply have to take 6 times the area of one side. But the problem is that, what is the length of one side of the cube? Okay, we know that the volume is actually 27 cm cube. Right? How do we get the volume of a cube in the first place? We take length times breadth times height, right? But then length, breadth and height, they're actually all the same value. So what we can do is, I will let the length of one side L. Okay, so L will be equals to cube root of 27. Because L times L times L is, maybe you will see it, will give us 27. Okay, in other words, L cube equals to 27. So L is equals to cube root of 27, for which it is actually 3. And therefore, the total area will be to take 3 times 3. This is the area of one side, okay, or one face, then we times 6. It doesn't matter whether you have brackets or not. Okay, I'm just putting the brackets to be clear to you. Okay, that my area of one face is actually 3 times 3. Right, and that will give us 54. cm squared.
After this is Chinese, right? We should hate drop as well.
Questions? Otherwise, before we go into this homework, we are going to cut this down. I just want you to do questions 6, 8, and 12. So no need to do 4B and 16. Possible to submit tomorrow. Right? I don't think you'll be submit tomorrow, right? Can? Otherwise, next I see will be after 7 holidays. Can? Violently object. Think that tomorrow cannot. I think Lucas say cannot. You think you can? Okay, now one in order in class say today can, then you can.
No.
Okay. Huh? You say cannot. So can or cannot? Then the rest of you left? Then like that how? Then when school open then you drop it is about yeah, well, that's why if you want tomorrow submit then you can enjoy holiday. Also Lucas saying can. Very fickle-minded, okay? So can we do that? Okay. Although I must admit holiday I give you some stuff as well. Okay. I will give you simple stuff. Alright? Okay, so let's do question 6 and 12 with you tomorrow, alright? Okay. Now, I'm still not done, still got time. So, I know that the SLS lesson was meant to be due today, and some of you have not yet done it, but a majority of you have already done it. So I'm just going to write on the majority, and I don't want to waste time. Okay. I want to talk a little bit about prisms to introduce to you certain terms about prisms. This is found in your textbook. Okay. So in the prism itself, what is critical is that there must be uniform cross-sectional area. That means that if I take a knife and I cut this thing in a certain manner, every single slice, imagine like your loaf of bread, every single slice will have to be the same. Okay? So if I cut this in the other manner, I'm also going to get slices of rectangles. Okay, so that will actually be a prism. Right? Some of you didn't recognize a prism. Okay, based on your SLS. Which is the question, Oh yes, this is the question. Okay, which one to put in a prism? Some of you think that these two items here, I hope you can see it. Okay, this is a pyramid, this is a sphere, they are not prisms. Because imagine you have a bread that is of this shape. When you slice it, okay, it is not all going to be the same size, same shape. Right? Likewise for this, okay, not all are going to be the same size, same shape. Right? Imagine this one like a Ferrero Rocher. You bite and then every single bite is different size, different shape, right? You don't eat before Ferrero Rocher. You never eat before, I shouldn't say bite for you, okay? Yeah. Alright, but sphere and pyramid, okay, they are actually things that we'll cover next year. Okay? Well, you're not children anymore, so don't want to celebrate Children's Day anymore. Okay, I mean, you don't get a holiday anymore. Alright, so very likely Children's Day you're having an exam anyway. Exam start already. Okay, so introduction to prisms here. Okay, in our syllabus we base here is the pentagon, okay, and then you notice that it is leaning to one side. Likewise, for this one, it is also not right. It's not a right prism because it is leaning onto the other side. Okay. So, yeah, show you this animation here to recognize a right prism from a oblique prism. So instead of calling it a slanted prism, we have a better name for it. It's an oblique prism. Okay, but you don't have to worry too much about that. Okay, because you're going to add right prisms most of the time. Now, for volume, I noticed from the SLS, most of you can get the idea of volume very well. Okay, because we know that, can I get everyone's attention? Okay, we know that volume is the amount of space that is being occupied, okay, that object occupies. So, for example, look at this animation. I have a prism because, okay, this is a hexagonal base one. The base is hexagon in shape, okay, six-sided polygon. Every single layer, if I were to cut it, okay, it will actually be the same size, same shape. But then I must only cut in this direction. I cannot cut in the other direction. Okay, so for prisms itself, there will just be at least one direction whereby I cut, and then every single slice is actually the same size, same shape. So looking at this, okay, when my prism over here fills up, every single layer adds on, okay, and when I do that, it is actually going through the height with one area going through the entire height. So that explains why volume of prism is base area times height. So that we count every single layer that fills up the entire prism. Okay. Then, just to end off for today, I want us to look at surface area, which I think some of you are a little bit confused and weak in. Okay, so again over here I have a prism that has a hexagonal base. When I open it up, it looks like this. Because there are 6 sides to your hexagon, there will be 6 rectangles. Just nice because this is a regular polygon, all my rectangles are of the same size. Okay, but we cannot assume that all the rectangles are the same. So when I open this up, okay, look at how it opens up. Okay, I notice that this length over here, okay, look at this long length over here. When it closes up, it goes through the perimeter. Okay, it goes through the perimeter of the base. You see? In other words, this length is actually the perimeter of the base. Okay? While this we recognize that it is a rectangle, so this graph over here will be none other than the height of the entire prism. So in order to find out what is the total surface area of all the rectangles around the site, I simply just have to take perimeter of base times height. I don't need to go and count individually the rectangles. Okay? This formula in fact it is foolproof because it doesn't matter whether your rectangles are they of the same size or not. If they are of different sizes, okay, it will still wrap up to become the perimeter of the base and then opening up to become a rectangle. Okay? Then after, of course, we need to find and add in the base areas of the two bases, okay, be it whether open or closed up. So if it's open, there is only one base. If it is closed, that means there are two bases. Okay? So this really explains to us why is it that the total surface area is actually equals to perimeter of base times height okay, followed by 2 times base area. Okay, and this is only provided if it is a closed prism. Right? So I hope that these things are taken down, okay, rather noted down in your worksheet itself that I've given you when it comes to the total surface area of a prism object. Right? So even for cuboids or cube, okay, cube usually we don't do this, but for cuboid, to save the hassle, you could also consider the parameter of base height.